So today we're going to look at back titration or indirect titration. Last time we looked at the general titration. So back titration is a little bit different compared to general titration because this titration involves two main analysis or practices, or rather two main titrations, because the first titration is your analyte is being reacted with your titrant, but in this case the titrant is added in such a way that it is in excess, and then that excess titrant is then titrated with a new titrant. So basically the main purpose is just to find the concentration of your analyte, but the only way we can do that is first finding the excess of the titrant, which we can get through titrating it with a new titrant. Yes, so back titration are usually done for substances that are volatile such as ammonia, for reactions that are extremely slow, or um, acids or bases that form insoluble salt. So this is an example of a back titration or an indirect titration. So it says a student pipetted 35 ml of um, cloudy ammonia solution into a 250 ml conical flask. 50 ml of 0.100 mole HCl was immediately added to the flask, which reacted with the ammonia in the solution. The excess unreacted HCl was then titrated with 0.05 mole sodium carbonate solution using 21.50 ml of that sodium carbonate solution. So calculate the concentration of ammonia in the cloudy ammonia solution. So the first thing we need to do is to draw a balanced chemical reaction between our hydrochloric acid and our sodium carbonate solution. And so we are starting with the last step of the titration, which is the HCl and the sodium carbonate solution. Because remember, first the cloudy ammonia solution was reacted with our hydrochloric acid. After that, the excess hydrochloric acid was then reacted with the sodium carbonate solution. So we want to first identify the moles of sodium carbonate solution, which will help us to identify the excess hydrochloric acid moles. Once we get that, we'll then be able to calculate the moles of the the moles of the ammonia in the cloudy ammonia solution. So the first step is to write a balanced chemical reaction between the sodium carbonate solution and the hydrochloric acid. So this will be HCl plus sodium carbonate aqueous to then give us sodium chloride, which is aqueous, to form carbon dioxide, which is a gas, and water, which is our liquid. And then obviously we have to make sure that it is balanced. So we have two sodium here, one sodium here. We add two, we add another two here. So now we have two chlorine, two sodium, one carbon, three oxygen, two hydrogen. Hence our equation is balanced. So the next step is we want to identify the moles of sodium carbonate. So in order to find the moles of sodium carbonate, remember in the question we are given 0.05 mole in a 21.50 ml. So we can use the equation of the number of moles of sodium carbonate equals to the concentration, which is 0.050 mole. So it's this concentration multiplied by the 21.50 ml. And remember, this is in milliliters, so we want to convert it to liters. So it will then be multiplied by 0.0215 liters. And therefore, the number of moles of sodium carbonate will then be 0.001075 moles. Good. Now that we have the moles of sodium carbonate solution, it's very easy to find the moles of hydrochloric acid because our equation is already balanced, and here we can already see that 2 moles of hydrochloric acid is required to react with 1 mole of sodium carbonate solution. So we just follow the ratio. So hence we then get moles of hydrochloric acid will then be 2 over 1. Remember this 2 over 1 mole, right? Multiplied by the, sorry, oh, this is moles, yes. Multiplied by the 0.00175 moles of sodium carbonate, right? So once we multiply that, we then get 0.00215 moles of HCl, right? Now remember these moles of HCl are also the moles that are in excess. So we can just indicate here they're in excess because these are the ones that after reacting with the ammonia in the first titration, right? So these are the excess moles we remain with. So the second part is to determine the amount of ammonia in the cloudy ammonia solution. So in order to do that, we will then have to identify the original moles of HCl added to cloudy ammonia. So you can just write it here. The next step is to determine the moles. Okay, let me just indicate. This is the second step. So to determine the moles of HCl in the cloudy ammonia solution in the, or rather that reacted with NH3, right? So this is the original HCl. So in order to get that, obviously we know that number of moles is given by concentration multiplied by the volume. So to determine this number of HCl, we then have to go back to our question. Our question says, so 50 milliliter of 0.10 mole of hydrochloric acid was immediately added to the flask, which reacted with the ammonia solution. And that is exactly what we are looking for. We are looking for the original moles of hydrochloric acid that was immediately added to the ammonia solution. So as you can see, we already got our concentration, which is 0.1 to then be 0.10, sorry, 0.10 mole multiplied by the volume. The volume is 50 milliliter. We have to make sure that we convert it to liters. So 50 milliliter will then be 0.05 liters. So our final number of moles of HCl will then be 0.005 moles. Now take note, this is the total, moles of HCl added. Okay, so we're gonna need this mole, so we need to indicate it well so that we do not confuse it. Perfect. Now that we have the total mole of hydrochloric acid that was added in the initial titration, and then we have the excess hydrochloric acid that reacted with our second titrant, which was the sodium carbonate solution. Now we just need to calculate the mole of hydrochloric acid that actually reacted with our ammonia solution, because remember, this is the entire hydrochloric acid solution that was added together to the ammonia chloride solution, but we need to know, we want to find out the actual volume that actually reacted with the sodium sorry, with the ammonia solution. So we're gonna do that. Just need a new sheet. Okay, so now we need to determine the, like I've said, we need to determine the moles of hydrochloric acid that reacted with the ammonia, and we can make use of this equation, which is moles of HCl titrated plus moles of HCl reacted with ammonia will then give us moles of HCl, which is the total added, right? So now what we need is we want to find out the reacted moles of ammonia. Remember, we already have the number of the moles of HCl titrated as well as the total added. How do we know that? It is based on our equation here. So the total number of hydrochloric acid added, we have it, it's here, which is 0.05 moles. And the moles of hydrochloric acid that is titrated, it is then here, which is 0.0215 moles, which we calculated here. So what we do, we just have to make this a subject of the formula. So this will be NHCl reacted with HCl. It will then give us, which means it's the total number of hydrochloric acid, the number of moles of HCl added, and we know the total is 0.0015, 0.001, okay, which is 0.05 moles minus the titrated number of moles, which is 0.00215. 0.00215 moles, and the final answer will then be 0.00285 moles. So that is the number of moles of reacted hydrochloric acid. Once we do that, we can then identify the moles of ammonia. We just need to draw a balanced equation of ammonia and hydrochloric acid, which will then be HCl aqueous plus NH3, which is aqueous, to then give us NH4Cl aqueous. And we already know the moles here, which is 0.00285 mole. And we know that 1 mole of HCl will react with 1 mole of ammonia, hence it will be a 1-to-1 mole ratio, hence moles of excuse me, so this was supposed to be the moles of HCl, so hence this will be a 1-to-1 ratio, therefore ammonia will also have the same number of moles. Therefore we'll then convert this number of moles to concentration, therefore our concentration will then be 0.00285 over the total volume, which was 0.035 liters. Therefore, concentration will be 0.0814 moles.